Good morning. Welcome to day 7 of writing a TCP/IP chat application. I'm Stephen Clary. Big shout out to my GitHub sponsors, and thank you for joining me. If you have any questions, post them in the chat as I go along. I will try to keep an eye on it. And with that, let's jump right into it. So first, a quick overview of what we have. Jump into the code here. All right, so we've got a server, we've got a client, we've got a few different layers here. We've got the pipeline socket that takes our byte stream from the socket, makes it a byte stream in the pipeline. And then we've got what I'm calling our chat connection here, which handles the parsing and serializing of our messages in and out of this byte stream. So our API looks like right now, public API. We've got this socket exposed. That's just for allowing clients to do socket options and things like that, which I'm not actually using, but it's a good practice to expose it. We've got this remote endpoint, which I'm using just as like an identifier, so to speak. Technically, a socket is uniquely identified by its source address, source port, and remote address and remote port, or local address, local port, and remote address and a remote port. And those four things together uniquely identify a socket, technically. A lot of times, though, if you're doing logs and stuff, it's just easy just to put the remote endpoint in there, and that's usually good enough. Okay, so, and then we've got reading is coming in through this async enumerable, so I've got this asynchronous stream of messages for reading. And if there's any, if the socket's closed or if there's any exceptions, it comes in through this async enumerable. And then we have for writing, we have the ability to send a message, which then it's asynchronous. Excuse me. It's asynchronous, but it completes at the point at which it enters our outgoing channel. So it works just like a socket write, where the write is complete as soon as it enters your local buffer. And then we have this ability to complete our writing. We're saying we're done with the socket, and this performs a graceful shutdown. So from our client side, right now our client is still just writing. So it connects, creates a new chat connection, and then later on it uses that to send a message, or we can close the socket. Our server side is just reading right now. So we've got like this main loop here that just processes all the input messages and also detects disconnection and any socket errors. So yeah, hi everyone. Yeah. Just as a reminder, the chat is delayed by 10 seconds or so. So everybody's saying hi this morning. Awesome. Okay, so this is what we've got right now. I think the next step is we want to have, right now we have a single client connecting. Well, we could have multiple clients connecting, that would work. And sending messages to the server, which just displays them on its console. What we really want to do is get those messages to the other clients, right, for a chat application. So today I'm going to take the step of adding on the server side this concept of like, here's my list of connections, right, or here's some kind of collection of connections. Say that 5 times fast. So this is a very, very common thing to have on the server side. There are probably some TCP/IP applications that don't need it, but I would say, real world, almost every one of them actually does. You need some kind of list at some point on your server app to say, to do something with all these different connections, even if it's just like list them in a list view or something on your UI. You usually need some kind of way to keep track of all those connections. So let's go ahead and add that in. So I'm going to create let's see. I'm going to put it in the server type for now, or in the server project for now. And I'm just going to call this let's do it connection collection, because that just sounds, it sounds funny. All right. And what we want to be able to do, this is going to internally have, some kind of collection of our chat connections, and then we want the ability to add ones to it, and we also want to remove them from it when there's some kind of a problem. So let's go ahead and say, so this is going to start off as just being a list or a collection. The thing is, we're going to need it to be thread safe, but we could just protect it with a lock. Yeah, let's do that for now. Okay, so I'm just gonna, hey, wow, look at that. Except I usually prefer to call mine mutex. It's a mutual exclusion. And what else do we want? We also want just a list of chat connections. There we go. And this would be our connections. Don't need that one either. All right. And right now our interface is going to be super simple. I'll probably move some of the other server app code right now into this class as we go along. But for now it's just going to be literally just an add. Which is going to be, that's right, lock the mutex, and then say connections.add. Wow. Okay, so the IntelliSense is actually pretty good here. I hesitate to trust it too much, especially in multi-threaded code, but so far today it's doing okay. And then we're going to remove the chat connection. And yeah, we can use object equality for this. Again, I mentioned at the beginning here deliberately about that the remote endpoint, and how that technically isn't a unique identifier for a connection. It's just close enough. But in this case, we would want something that really is the unique identifier of the connection. Or in this case, we can just use the object equality. So I'm going to do reference equality for this. Let's go ahead and lock the mutex, which everything actually uses by default. Your class types use by default, so that's awesome. And I'm just going to call connections.remove. And that should do it. So I've got this thread safe list, right? That only supports add and remove. And then we also want the ability to get all of the connections. Now, the semantics that I want for the read here is a snapshot. Okay, so when I call this read, I'm going to want to say, give me all the connections that I have right now, and as a snapshot. I don't want to deal with any kind of, well, the underlying collection has been modified, exceptions from the enumerator, or anything like that. So I'm going to return not connections. That would be a big mistake. Actually, sorry, let me lock this. We want to lock it and then actually copy it, doing a shallow copy. So I'm just going to do to list. And that will create a copy of my list. So this gets me a snapshot. As long as we don't have too many connections, this should be sufficiently fast. And the vast majority of use cases here this will be fine. Performance-wise. So now I've got this connection, and what I'm going to do is I'm going to come over here and I'm going to say, whenever we have a new connection, I'm going to add it to our list. Oh, I don't actually have a list yet. So The connection collection. Sounds like that should be like a song or something. Call that connections. New it up. And we're in a namespace scope. Right. I'm not used to this whole new way of doing this thing here. Okay, so I don't really know how to fix that. So, all right, I'm going to create my own little server type here just to hold this. Or another possibility is to just create a new one up here. All right, so let's just extensions. Connection collection. That's really a horrible name. I apologize for that. The question is this a local method or is it just a top-level method? Can we access connections in here? Yes, we can. All right. So this will work just fine. So then we add the connection to that. At the point it's disconnected, we're going to remove it. Or if there's an exception, we're going to remove it. So I'm just going to stick this into a finally to remove it. Oops. Connections.remove. Check connection. Yes. And the other thing that we want to do is then take, every time we get a message from this chat connection, I want to broadcast it out to all the other chat connections. But before I do that, I'm actually going to update our protocol. So it's been a little while since we looked at the protocol. So this is like the official protocol of what we're developing. Should keep it up to date as we go along. Sometimes I forget. Actually, this protocol currently is missing a couple things. So first off, every protocol should be versioned. So this is going to be v 1.0. When it comes to versioning protocols, you don't really have to do like full semantic versioning. I mean, you should do semantic versioning, okay, but you don't need like 3 numbers is what I'm saying. Because, well, I guess you could. So the idea behind protocol versions is, your major or your minor versions should still be backwards compatible. That's where you add features like, and major version numbers are where you're going to have to. It's like a completely different protocol. Look at HTTP, for example. HTTP version 1.0 and 1.1 are very compatible. HTTP version 2, quite different. And HTTP version 3, very, very different. One thing is you should definitely version your protocol. I'm just going to keep mine at 1.0.0 because the idea behind this exercise is by the time we're done, this will be version 1. So I'm just keeping it at version 1 here. But you should definitely have a version, also have a changelog. So mine's just going to be v1. Whatever. Or I could walk through here and do let's do that. So let's take the versions as we go. So we already had 0.1. This is essentially version 0.1. And now we're going to change it to 0.2. This is still pre-release. Right? So this is the initial incomplete version. And we'll stick up v0.2 here. What I want to do today is, so first off, we need to add that message coming from the server, going back to the clients, And secondly, I want to clarify something that I'd written earlier. So first off, this chat message here. I want to clarify this one because a lot of the time in TCP/IP protocols, messages only go one direction, right? So even though from a socket perspective, your connected socket is the same on either end once it's connected. You know, on the one side you've got a listening socket, it listens and accepts. On the other side you've got a socket that doesn't connect. But once they're connected, that connected socket on both ends is exactly the same from a TCP/IP perspective. But when you're talking about real-world TCP/IP applications, usually there's still a distinction between client and server. So usually, and not always, but usually most messages can only go one way. So what I'm going to do is I'm going to say here in this chat message, actually I'm just going to put it in the title. So this is going to be client to server. I'm just going to designate that. This type 0 chat message only goes from the client to the server. And the reason for that is when I add my new chat message, so this is essentially a chat message, also called chat. Well, I shouldn't call it the same thing. I'll fix that in a minute. But this is the server to client, and this is a little bit different, right? So we have because what we need to do is not just give you the message, we also have to tell you who's saying it, right? So there's some additional information on this message, and we can structure that differently, right? You know, this is your protocol, you're making it up as you go. You can say, well, maybe this one can go in either direction, and it has a from field that can be empty, you know, or something like that. But I think that kind of complicates things a bit more than I like to see in a protocol. So I like having these being, you know, separate message types. This is just personal preference. Separate message types. They each always go one way with different data, and that way there's no like optional data or could possibly be missing kind of data. So I've got the chat message from the client to the server. The server knows who's talking, and then a chat message from the server to the client. There's something in the chat here. I suppose the name or nickname of the sender is going to go somewhere directly inside the text or a parameter. Yeah, so I'm going to add this in to this message here. And yeah, so right now there's not a way to like set nicknames. I'll be getting to that probably near the end. But for now, our source or our nickname or from field is actually just going to be like the remote IP. I'm just going to do that in the meantime, and then I'll add the set. Here's how we set our nickname a little bit later, because that'll be illustrating command response, another very common pattern here. But we're not ready for that yet. So for now, I'm just going to encode the remote IP in there. So now at our protocol level, this one's pretty easy. This chat message, just say, the payload, which it already has a length defined because of that length prefix. We already know how big the payload is. And that's just a UTF-8 encoded string. That's pretty easy. In this case, we've got multiple fields. Okay, so now we have to kind of introduce something that is common in a lot of protocols, and that is some different types. So what I want is like some kind of a variable length string, because now we have two fields going into this single message. Not just the message isn't just one field anymore. It's not just the message. Now we have two fields. So I'm going to say, let's call this a variable length string. This is a very common thing in TCP/IP protocols. So again, I tend to like length prefixing. Just thinking there's a couple different ways I can address this. we can go with like a short string and say your nickname is, limited to 256 bytes, or we could do like a full length string, which is like a full, you could say that's a 4-byte prefix on it. Let's do the short string, just to show how this can be a little different. So this would be a length prefixed string where the length, and of course, and specify your encoding, UTF-8 encoded string, where the length prefix is a single unsigned, is a single byte unsigned integer. So you can range in value from, or range in length from 0 to 255. That should be enough nickname for anybody. Old joke. All right, so yeah, so we'll do that. We'll see how good it looks. I don't know. The payload of the message has 2 fields. So first we've got a nickname, or from. I'll just call it from. A variable length short string. And don't forget, as you're writing your protocol, right now it's like really obvious what from means. Someone coming along looking at it later may not know what that means. So don't just say, how to parse it, but also say what it actually means. Representing the source client of the message. Sure. Okay. Length prefix is set by the client as part of the message. What happens if the length is provided incorrectly? There's no end, and the server will just assume that the next message is the next byte. So, yes, in this case, you trust your clients are accurate. Yeah, at some point it does have to come down to trust. There are things you can do on the server side to avoid misbehaving clients. And you'll see this a lot like in HTTP servers, right? Because they're public. My experience with TCP/IP applications has mostly been embedded devices, dedicated networks, that kind of thing. So we didn't have to deal with any kind of, what's the term? Hostile clients, right? Nobody's like deliberately sending you bad information or anything like that. If you get bad information, it's because of a bug in your own code. That's easier to deal with. But yes, so length prefixing, actually any kind of message delimiting has the same problem. Well, what if somebody sends, a 4 gigabyte buffer and then just never actually sends the rest of the data? Or what if somebody sends the wrong length prefix? So there isn't a great solution for this. What you usually end up with is some kind of, it can be like corrupted data coming in if the length prefix is wrong. If they're sending a large length prefix and then just wait for a long time, then you have to have some kind of like a timer or something to say, all right, you're clearly not behaving correctly. I'm going to cut off your connection. And that's how, for example, HTTP servers work. If the client sends a content length or whatever for their body and then just never actually sends the body, the server will actually cut them off. So if you're talking like out on the internet, public facing, there's a lot of security related things like that you have to handle, and I don't even know what all of those are, so I'm not planning to cover that in this course. I am going to mention that again at the end, that this is not something you can just toss on the public internet. Okay, so after a few bad messages, just drop the connection. I would say like after the first one. So if you detect something, if you can detect a protocol violation, you should just close that socket immediately. Because sockets are streams of data, or streams of bytes, so the ability to actually recover from a bad connection is, or a badly behaving client is usually just an exercise in frustration. I don't think it can really be possible in the general case. Okay, yeah, so Matt mentions here, I opened a port on my socket server implementation. It's amazing how many random survey bots connect. Yes. Anything public facing, I mean, port scanning goes on all the time on the public internet. So, so yes, you have to have a lot of hardening of your server before anything like this can actually go on the public internet. We're not even to that point yet. We're still not even at a complete implementation. And I don't mean like passing chat messages back and forth. I mean, there are parts of this implementation that are still wrong. So I'm hoping to get it correct first and then discuss the remaining things you would have to do to put it on the public internet as far as I know, which isn't a lot. Okay, so we've got our chat message here from the server to the client. I got to rename that thing because I'm going to call it broadcast. If I can spell. Just so that it has a different name than chat message. Chat message is already like way overloaded in this code. The chat term especially has too many different meanings for me to be comfortable right now. Okay, so we've got a variable length short string saying here's the client who says it, and then we've got the message. Now, we can do this a couple different ways. What we can say is the message is just like the remaining data in this message. I didn't say what this means either. Representing the chat message the client sends to the server. I'm not a huge fan of protocols that just say, and the rest of the data is this. I'd rather have like everything compartmentalized in with their own known length. I think for now, I'm going to do it this way. I might change it later and see what that looks like. So, so this would be the remainder of the message representing the chat message from the source client. Okay. So now we've got this new broadcast message type. Added, yeah. Okay, so we've got our type 2 message. All right, type 1. It's our second one. It's type 1. You count from 0, right? All right, that looks right. So we could also, well, all right, we'll leave it at that for now. I think I might structure this a little differently just because of how I prefer my own protocols to behave. But for now, we've got, so our chat message 0 has not, you know, I forgot one other important thing. I apologize. I should have mentioned this back with versioning. So we've got a version on our chat protocol spec, which is now 0.2, still pre-release. But the idea is that you want to allow for future versions to be used and then fall back to this version. So ideally, you have some kind of a protocol negotiation kind of thing going on. However, there is a nice little trick you can use, and which I use all the time. If you don't want to design and implement protocol negotiation up front, because that can be a hard thing to test when you only have one version of your protocol anyway. Actually, what's the one I was looking at a couple weeks ago? The new the Quick protocol. They actually came out with a Quick protocol version 2 that is actually almost exactly like Quick protocol version 1, and they just do it to test out the version negotiation, which is clever. But there's a nice little trick that you can do with your own TCP/IP protocols, and that is you can say, so any message under message definitions, I'm just going to say any unknown message types should be ignored. Okay, so that way, if there's, you know, that allows us to add extensions in the future. So you could say, your type 17 message or whatever can be, hey, do you support this protocol version? Because I support this list of versions or something like that. So that allows you to add protocol negotiation later when you need it. It's just a nice little trick there. So that would fall under this got unknown message there. So now we've got our chat message already defined. That's type 0. Now I'm going to define a broadcast message. So I'm just going to take this same idea here, and we'll add a broadcast, if I can spell. For some reason, I have a very hard time spelling broadcast today. So we'll take broadcast message, and in this case, we have a source or from or whatever. From, I called it. So I'm going to call it from in the code. And text is fine too. Actually, I like text better than message. I'm going to change that in my protocol. So this would be chat message. The payload of the message representing the chat text. This message becomes text. This message still means message like delimited messages. So I'm just removing this ambiguity. So it's now the chat text. And then this payload of this message, yes, the source client of the message, this one can be message or text. I'll leave it as message. The remainder of the message, which is delimited message, representing the chat text from the source client. So, terminology, very, very important when you're dealing with protocols, and the terminology here is still not quite where I would like it. It's just something to bear in mind as you're designing a protocol. So we've got our own public string from. Now we've got a from and a text here for our broadcast message. Now we need to define how to serialize that in and out. That comes into play in our chat connection. Yes, so here we go. So when we are writing from our channel of messages into the pipeline, we've got this one handling the chat message. Else if message is broadcast message. Then what I'm going to want is we have, all right, it's been a little while since I looked at my serialization code here. So what we're doing up here is we're writing, okay, so we've got the length prefix, we've got the message type, and then we've got, in this case, just the message. And in our case, we have a length prefix, message type, a single byte length prefix with the from message, and then the remainder of it is just the text bytes. I'm going to change this to text bytes. We're naming that all text now. This is the text part of the messages, not the message. Okay. So I'm going to say, first off, we've got, so our from is also going to be UTF encoded. And here's kind of the problem here. So what do we do if this is too big, right, is the problem. And what I'm thinking is, it's really hard to say, restrict this string to a value that only will only fill up this number of bytes. That's just a hard thing to code, because with like a UTF-8 encoding, they can go up to what? A single character can go up to what, 4 bytes, I think? Maybe more, because you can't split surrogate pairs either. So anyway, it's a complicated problem. to say, oh, this is too big of a from field. For now, I'm just going to punt on that. I mean, it's solvable, but I'm just going to say if this is too big, 255 is our maximum because we got a single byte length prefix. Then I'm just going to throw, and I'm going to say, too bad. There are ways you can like trim that down and try to find like the most you can fit in and that kind of stuff. I'm not going to worry about that. Okay, so we've got our from bytes, and then we've got some text bytes coming in too, which is going to be just like this except for the text field. And then how much memory do we need? This is a question. Actually, I'm just going to copy this here, and we will modify it. All right, so we're going to take our memory, and we want our text bytes and our, well, let's add this up. And sometimes, you know, what I did up here was text bytes.length plus 8. That's actually kind of unusual for me to do. Usually what I want to do is like put out each field individually. So we would say our length prefix plus our message type plus text bytes.length. This is more common for, I think it just makes the code a little bit clearer. And I'm going to do the same thing here. So we've got length prefix, message type, we've got our from length prefix, our from bytes, and then we've got, oh yeah, so there's no prefix on the text. There's no length prefix on the text field. It's just the remainder of the message. So that's it. And then, you know, the text bytes. Okay, so this is how much memory that we actually need from the pipe. And then we can write in our length prefix. And you know, what I'm going to do actually is say message length. I'm just going to calculate this out separately at this point. So it's everything except for the length prefix. Remember from our protocol, every message starts with a length prefix. This length is the length of the message, not including the length prefix. So that's why we have, this is the actual length of the message, and then we have our length prefix stuck in front of that on our, for the full memory span. All right. Constants for even clearer sizes, says Freddie. That's a good point, and yes, you should definitely do that. That is an excellent point. So we have like our length prefix size and that kind of thing. I'm just going to finish out what I'm in the middle of here, and I might refactor to include that. Thank you for that. Okay, so then we've got our, we need to write our length prefix. And this is writing into that span. And we can write the message length instead of computing that over and over again. And then we can write our message type, which is 4 bytes in, and it's a message type of 1. And then we have a length prefix for the from field is next. So in that case, we would write, I don't think it makes sense to call did I call that a big endian? That would be funny. Okay, single byte unsigned integer, right. Endianness doesn't matter if you only have 1 byte. So then, let's see, memory at, I don't know, can I index into this? It looks like it, okay. Again, I'm not that familiar with the buffer types. So this would be at, what's our offset now? 8. is actually going to be equal to the from bytes dot length, yes. And it looks like I can't do that. Cannot apply indexing. Okay, that's fair enough. How do I do that? And slice into it. Huh. Can I slice into it with a span, maybe? This is a test there. Whatever. Okay, so it looks like I can write into the span. That looks really weird. I'm not liking that syntax, but actually I'm gonna look into something else because I'm thinking we have a sequence reader. Do we have anything that can do this? That can write to, I don't know, is there a sequence writer? I'm going to look into that as soon as I finish up this this code here. Okay, so this looks like horrible syntax, but essentially it's setting only a single byte of being the from the prefix, the length prefix for the from field, and then we write out our from field, which is going to be actually essentially this. So we're going to take our from bytes, copy that into the memory. We're slicing it at 9. Okay. And then the remainder of the message is going to be our text bytes. Now we're slicing into this at 9 plus whatever our from bytes length is. Oops. And that should be enough. And then we advance. Instead of text bytes length plus 8, we're going to advance by the length prefix plus the message length. Okay. So I think that's correct. This serialization code is getting pretty ugly. I'm going to start writing some helpers here to deal with that if the BCL doesn't give us anything. Okay, so I'm going to clean this up in a minute. But in the meantime, I'm going to, let's see, so we've got, how do we read it back out? Right on. See, what I want is something like the sequence reader when I'm writing. So let's handle our other side of our serialization. And it's nice that this is now in the same class. Oh, else if, duh. Okay. Let's see, so this is going to be, so we've got chat message bytes. This is actually going to be text message bytes. Actually just text bytes. Okay, so we already have a length prefix and we already have the message type parsed out at this point in our parser. So let's see, what I'm going to do is say, okay. So in our new broadcast message, we have a short string, right? So we've got 1 byte that we want to read from this sequence reader. Let's see here. Try read reads the next value. Yes, that's exactly what we want. And this would be the from length. If it's not present yet, then yeah, then we do our usual breaking here, saying, here's where we're at. Let us know when the complete message is here. All right, so now we've got our from length, which is just a single byte. And then we're going to read in our from bytes. It's going to be the from length, and that's it. And then we're going to actually just copy it out in a very similar way that we do up here. Again, helper methods are going to be coming here. All right. So, question. Yeah, so yeah, Matt and Freddie are both asking for constant values. Yes, we're going to be cleaning up this code after we finish writing it. Message protocol should contain text instead of message as the property name. Like in my class, the message protocol, like down here? It is. Yes, you're right. This should be text. Absolutely correct. Okay, good call. Thank you. All right, so we've got our, so we're reading in the from bytes now. We're reading in that from field. Again, a lot of copy pasting right now, some magic numbers. We'll be cleaning that up in a little bit. So we try to copy to this, and then we can say advance. I'm just going to go ahead and stick this in an else block. I think I like it better, just to make it clear that that's what's happening here. It's like all part of a single operation. So I'm kind of like using vertical white space to delineate, here we're reading this field, here we're reading this field. Now moving on to the next field. So then what we have left is the text bytes. Actually, I'm just going to copy that again. Just copy this. Now in this case, we do have to do a bit of math because our protocol just says the remainder of the message, right? And again, that's not my favorite way to design a protocol. I like where everything has their own length prefix, but I'm just going to do it this way for now. So in this case, we're going to have message length, not message length. What did I call it? Length prefix. Okay, so it's actually like literally length prefix. And we have to take off the ID of the message. We have to take off the single byte length prefix, so the from field, and then the actual from field itself. And whatever remains is the length of the text field. So then we're going to do this, same exact thing here. And then at this point we have our complete message, and we can say, we can add it to our result. All right, so this is going to be a broadcast message, and we are going to pass in the from bytes and the text bytes in that order. All right, going off the screen a bit. Right now. So now we've got our, now we should be able to parse and serialize out a new kind of message, a broadcast message. Again, I'm going to come back here and clean this up a little bit. But the parsing and serialization code is always a little bit awkward. Can never get great. So let's go ahead and build this, see what happens. And no, I forgot something here. What we got here? Yeah, okay. Don't know how I missed that. All right. So now we have, on the server side, we've got the connections, showing all the connections. Now what I want to do, on the server side, we've got that new message, now we want to use it. So if a chat message comes in, what we're going to want to do is like add some real actual handling here. We can display, we got this message, that's fine. And then what I want to do is say current connections. So this does a snapshot read. Now I've got I read only list, I think, of the, I read only collection of the current connections. And this will, and then what I want to do is go through each one of these connections and send to it. So I'll just explain as I go. Except we don't want to send it back to the client who sent it. So you can't use not equals here. You have to use, you can't use the not equals operator. You have to use not dot equals, which is kind of awkward. So mine is chat connection dot remote endpoint. So for everyone that has a different remote endpoint, so every chat connection that's not mine, you know what? Forget the remote endpoint. We're not going to use that as an equality, as an identifier. What I actually want to say is object equality. So X is not chat connection. Easier, simpler, and also more correct. All right, so for every other connection, then I want to actually send a broadcast message to that connection. So I'm going to say, I'm just going to create like a from string, which is right now just going to be my chat connection dot remote endpoint to string. Yeah, that'll work just fine because we're seeing that in our text message or in our console lines here anyway, so that should work just fine. So I'm going to say that's where I'm sending from, and I'm going to say, all right, so here's my other connection, and I'm going to send a new broadcast message. That's from me, and it has the chat message.text, yes. And of course we have to await that. Really that should be async. I'm going to change that right now. I don't know how I missed that earlier. That should definitely be called async. Thank you. All right. So jumping back. The one thing that we have to, I didn't jump back. There we go. So the one thing that we have to be aware of is there's a bit of a race condition here. Because I'm using snapshots, I can get back some connections in my local list here, my local list of current connections. I can get some back that aren't viable. Maybe they just closed, right? Or maybe they just entered an error state. And if I try to send a message to them, it is possible that, well, actually, is it possible with the way we've set it up? I'm thinking that send message async may actually throw an exception. And we want to avoid that. But I'm not sure if it actually could. Let's jump into that real quickly. In the general case, if you're dealing with TCP IP sockets, you want, like in this kind of case where you're doing like a broadcast, you don't want exceptions to take down your sender, right? So I'm just going to do that anyway. Even if in our specific case, because we've got the channel buffer and all that, send message async may not actually ever throw. But in the general TCP IP application case, sending a message can throw. So I'm just going to say ignore it. So really what we're doing is we're trying to send a message to each connected socket. If the socket happens to disconnect at a very inconvenient time, just ignore it. All right. Looks good. Let's compile and try it out. See what happens here. Start off our chat server. Let's kick off a chat client. That was a lot of code being written without actually even running anything. So let's see here. If we connect, we got the connection. I can send a message. Oh, what is this? Oh, I have a breakpoint in there. Never mind. sent to hello server, and got the message hello server. Okay, there's no other clients connected, that's fine. So our basic, I'm sending, you're receiving still works. Now let's toss on another client here. Just gonna open another window, and which I guess I didn't have to do, but let's run another client here. So now we've got 2 clients. Let's see what happens. Got a connection. Now we should, on the server side, we should have two different connections in that connection list. So this is going to be my big test here. Let's see if this works. I'm going to send it from one. Got the message, big test. And of course, we're not actually reading anything on our client side. That's what I'm forgetting. All right, so never mind. Let's shut this down. All right. So I think what's going on is the client sent the message to the server, and the server sent the message to the other client, but our clients aren't actually listening for messages yet. That's what I haven't added. Okay. I'm going to read it through some of these comments here in the chat. With the use of task.one, all here, be okay to send all the messages? Yeah, to broadcast all of them. Yes, absolutely. That would be perfectly fine, actually, and not a bad idea, and actually a really good idea. And actually, I'm going to do that. Thank you. So what we actually want to do here is say each connection. Yeah, actually, you don't even need that for each anymore. So what we want to do here is say, because that way, if one client is reading slowly, it's not going to hold up the broadcast message for all the other clients. That's where the benefit of this really comes in. You can broadcast to all of them at roughly the same time. And we're just going to do this right here. And then we're still going to need our try catch, right, in case one or more of them throw an exception. But then we can just try catch the single wait task done when all. Yes. Okay. Good point. Thank you. Thank you, Freddie. All right. So the other thing that we're missing is we need our chat client to listen. I'm going to go ahead and finish up this today, although we're at close to the top of the hour. I'm going to go a little bit of overtime here. Just want to see this get hooked up. So we should have been listening on our client socket anyway, because that's how socket closure and errors are reported up to us. So we really have to be listening anyway. So we're fixing a bug as well as adding a feature here. Just making that clear. So we've got our new chat connection, and then we want to essentially do a processing. It's very similar to what we have on our server side. So I'm actually going to steal that code. Yeah, so I'm just going to steal this little process socket method here. Oh, you know what? Actually, on the server side, now we've got these this list of connections and stuff. Well, the basic structure would still work. That's still what we're looking for. Yeah. All right. But I'm going to be reusing much less of that code than I thought. So we'll just create this new method here. Process a socket connection. We don't have a list of connections. We're actually getting... We actually have a chat connection as a member variable in this class. And the main thing is we want to read it in, and then all our processing is going to be completely different. And then we don't have that removed. Okay, so we didn't really end up reusing a lot of that code. That was not really necessary. All right, so actually for this process socket, we do want like our own local chat connection object. because even if we like disconnect and reconnect, this process socket shouldn't change from one connection to the other connection. So this one should be a local variable. And we're not looking for chat messages, we're looking for broadcast messages. And then I'm just going to change these console.write lines to be writing out to our log.txt instead. So we can still say, hey, we got an unknown message from my server, \n. We can say our connection was disconnected from the server. Now we've got that. We've got socket errors. We had some kind of problem with the connection from the server. Now our client is able to detect all of these things as well. Okay, so our broadcast message, we want to handle this by actually just writing to our log.txt also. So we can say got message from, actually I'm just going to say it like this. Broadcast message.from says this. All right. Now we just need to call this process socket. So when we create a new chat connection, we've connected to it. Then we also want to, I'm going to fix this discard later. We're going to process the socket and pass in that newly created chat connection right there. All right, I think that would work. Let's see if this works. So we've got our chat server running, and then we're gonna kick off a couple chat clients. Got one here, kick off another one. So we've got two different chat clients. Let's see what happens. Dun, dun, dun. I'm gonna move this around so we can see everything at the same time. Okay. So this one's going to connect first. It connects. All right. We're going to send a message. It's fine. Oh, well, that's interesting. So it did actually get reflected back. Okay, so that's not expected because we shouldn't have done that. I will look into that. In the meantime, let's connect this one. And let's see if we can send a message from here to here. Welcome to the chat. And we'll see if that shows up on this guy's log over here. If I send this, it does. All right. So let me say sent message, welcome to the chat. And for some reason, these messages are also being reflected back. And here we have welcome to the chat. So this one did send a message to the server, which then broadcasted out to both of them. I'm not sure why it's including this one, but it does include the new client as well. So we've got that broadcast message working. Looks like I'm missing a \n there in my log, so I'm just going to grab that real quickly. There. All right, just to clean up the log. And then there's something still wrong on our server where we have, oh, because I had the for each doing a where, and when I changed it to a select with the task.whenAll, it does not do the where anymore. So see where X is not my own chat message, chat connection, not my own chat connection. There. So now we're properly filtering that out. Okay, yes, Michael points out you didn't filter by your remote endpoint. Exactly, yes. I removed that filter when I put in the task.whenAll by accident. So now it should work. Let's just run it to test it one more time here, which I can't do because I'm still running. There. All right. I just want to test this out one more time, make sure it looks good, and then we will push the code and call it a day. So I've got a couple clients and one server, and I can say we can connect here, say hello server, and I'm not getting that reflected back now, which is good. This other guy can connect over here, and then I can say welcome. And when I send it, it says I sent it, the server says I got the message, and then this other chat says, this other guy said, welcome. Perfect. All right. So, so in review for today, Day 7, we've added on the server side, a list of connections or a connection collection. Somebody's pointed out, who said that? It was Matt. Matt said, it sounds like a 90s rap group. Probably a good indication I should change the name, right? So the connection collection is now on our server side, so it can manage like, okay, this message then affects these other clients. We're just doing a very simple TCP/IP chat application, so everybody's in the same room, you know, and if you send a message, it's broadcast out to everybody else. You know, very simple stuff. You can make that as complex as you need now that you have that connection collection. So we've got that all working. And we also fixed a serious bug in our chat clients because now they can actually detect when the server goes away. So if I were to say like kill this, then both of these chat clients got notified. Oh, you know, your server went away. There is still one major bug remaining. This is still not even correct. So I think next time we're going to look at keep alives and why they're necessary and how to integrate them, how to send them. So we'll be updating our protocol with some keep alive messages, and we will be implementing that in a way. I think I'm going to try to do it in a way that like our applications, our client and server, don't even have to be aware of it. If I can, I'm going to put that all into the chat API side of things. But anyway, we'll be looking at keep alives and why they're necessary next time, day 8. And then the only other thing I'm planning to cover in this series is like actually having a command response style of message, which is again very common in TCP/IP application, you know, real world protocols. So I think I'm going to do like the nickname, set my nickname to this as like a command, and then the response will be okay or no, that nickname's already taken. Okay, so that concludes for today. Thank you very much for joining me on day 7 of TCP/IP chat applications, and we'll see you next time.